Hey YouTube, JP Dillon. Hopefully this is the last and final video you'll see of this monstrosity as far as the repairs. We're still going to clean up the faceplate a little bit after this. This is the 5500, and where we're at right now is we have no stereo decoding, no separation. I've got my Soundtech 1000 up here with the pilot level cranked up, and if we go between left and right, it just attenuates a little bit because it's not decoding. And even if I crank up the pilot signal to about 200%, it just doesn't do it. So something's not working. So we're going to figure out what that is. This is the multiplexer. And basically the way that it works is the signal comes in here. It's 19 kilohertz. It's amplified. And then what it does is it goes through a doubler circuit. And then you're switching and muting down here, and then finally there's your demodulator and your low pass filter and your output. And so what we need to do is find out why this thing isn't working. So we're going to check voltages. We're going to see if our 19 kilohertz pilot shows up, and if it's being doubled. Really the points of failure is lack of amplification here. This could be open. One or more of these diodes could be bad. Also, as you can see, this amplifier goes to a switching circuit here. And what this does is this detects whether there's a pilot signal or not and turns on the doubler and demodulation circuit here. So if there's not enough signal here, this doesn't turn on, and therefore you get no lamp, you get no decoding. So we have to look at that too. So, yeah, let's go ahead and get a scope on it, and we'll see what shows up. So looking back here, this is 401, which is sitting back here. So let's see if on our base, we've got our 19 kilohertz. Looking at the top, it appears like we do. Let's go ahead and just switch over to that and get rid of our audible signal so that we can better trace that. So there's our 19K, and if we go to the collector, we should see an increase, but we don't. That's times 10, times 100, nothing. And we got this tiny little signal here, which appears to be no different on the base than it is on the emitter. So right away, we need to look and see what the voltages are on this device. There's supposed to be 5 volts on the emitter, and let's see here what they have for this. There should be 11 volts on the collector. So let's get a meter and see. Alright, so we're going to come to the emitter. We got 4.4 volts. We've got 22 volts here. That's too high. We got 5 volts here and 4.4 here. So this 0.6 of a volt across this device, but there's no current draw. There should be 11 volts there because it's being supplied through a 3.3K resistor, which is, let's see, R441. Where's that on the board here? Can't really see it, but I suspect that this device is open because it's not drawing any current. There's zero amplification at the collector. There's no signal at the collector. We should see something here, something big. It should be amplifying it about 5 times. So, let's see. You are a 2SC871. Let's see what that is. Alright, so according to the Japanese transistor manual, a 2SC871 is a 30 volt, 200 milliwatt, 125, it's 30 milliampere, 200 milliwatt device at about 150 megahertz. So, there's a couple of choices for that. What I have on hand is a 2SC2547. You could use that, a 2SC2240. You could use a 2N 55, 51. Just make sure you put the leads in the right hole since the pinout's different. So let's see how tricky it is to get to that board. Well, we certainly aren't getting to that section of the board from the bottom because it's way back in there. I would have to take the entire regulated supply and that sub chassis out. So we're going to have to see if we can get that board up, and hopefully there's enough slack on the cables that allows me to do that. Alright, let's get the screws up. Yay, magnetized screwdrivers. I gotta get me a tripod. Of course, I've got a completely decent high-def camera. It's just easier to shoot it with the phone because obviously all of my software and everything is just here, and you can just boom, edit it, upload it, and you're done. I just rarely have time to sit in front of a desktop with software anymore. Alright, so what's holding this down? Must be a grounding tab. Yeah, there is. You got this grounding tab down here, and you've got another one down here. Lovely. Why couldn't they have just put a wire on it? Ugh. Now I gotta desolder those. Well, when it came right down to it, I just had to pull the board up anyways. So I just unsoldered some wires on the power supply board and we got it up. And down there, that little guy right there is the guy we're gonna take out. And then we'll put him on the checker and see what he tests as. I'm pretty sure he's open. Just doesn't read right, not drawing any current. So our first stage amplifier is open, and if there's no 19 kilohertz pilot to switch on the circuit, it ain't going to do much of anything. So let's go ahead and get that out of there and test it. Alright, so here's the little bastard that's out. No real signs of beach disease or anything that would have killed it over time. Let's see what our little component tester says. Okay, so here we all hooked up. It says it's a transistor. That's good. It's not defective, or at least so it says it's not defective. It's got a current gain of 544. That doesn't seem right. That seems way too much for that device. And it's using a 2.5 milliampere test current. Base emitter voltage to turn it on was pretty high, 0.74. That seems too high for that little device. No leakage. Interesting. Let's see what the book says again. See, looking at the details again, we come to the HFE or beta section. That guy right there. And if we go to the 871, it's supposed to have a beta of about 270. I think that's the maximum. That's the maximum they want. So that's the 500 and something just doesn't seem right. So let's see if just popping another transistor in there fixes the problem, because that just something about that doesn't seem right. And the fact that we're getting 22 volts here, the base emitter junction is on because there is a 6/10 of a volt drop across it. But if the supply voltage here is 11 volts, and I'm getting 22 here, that's odd. I mean, there could be something wrong here in this circuit, which we can look over too if replacing the transistor doesn't solve it. That's odd. The other thing that ticks me off about this is that they don't say what the supply voltage is coming into the board. There's nothing that denotes what's coming into the board. I mean, the highest voltage I see here, there's 14 volts here. And I know on one of the schematics we were getting like a 27 volt and then like a minus 35, well, some sort of weird asymmetry or something like that. But anyway, let's pop the transistor in there and see what happens. Alright, so with the new transistor in, let's see what it's doing now. Let's turn down our sine wave so it doesn't show up there. That's what we got going in, kind of tiny. and we still got next to nothing coming out. So not the transistor. And then let's see here if we are still parked at our 22 volts. Yes, we are. See, the voltages here are a little low, so something's not quite right here. Let's see, I've got 4.5 on the base and 3.9 on the emitters. It's even lower than last time, so something's not quite right here. So let's take a quick look again at the schematic and try to figure out what else could be pulling this down. And let's see. So here's our switching circuit. I'm trying to see what else would be a possibility here. I'm trying to trace out this power supply line and see where it comes from. Okay, so we've got a 24 volt line that comes in. That makes sense. Going through that 47 ohm fusible, which then goes to the collector lines there. Alright, so I was misreading that. So on TR409, which is your switching supply, we should have 11 volts on the downside of that 3.3K resistor. That's R441, which is near TR409. Let's see where we can find 409. There's 410 right there, next to that pot. 412, 403. Here's 409 back here. And we can see upside down there, TR409. So let's see what this is doing. This is your on and off switch. But you see, that would detect, there has to be a signal there for that to work. Okay, so we have 12 volts here from 11, and we have 3.75 on the base, and 3.1 on the emitter. So that's doing what it should be. So the switch is, I guess, currently in the off position. Because when this is active, all this does, so you've got a capacitor here and a diode to rectify that signal, which then turns on these two switches, which then starts the demodulation process. So really, I'm just wondering why we're not getting any signal here. I just don't think these voltages are high enough, because it's supposed to be 5 on the emitter, and we're getting 4. And we're getting 4.5 here. That's a 0.5 volt drop. In theory, that should be alive. So, yeah, that's a little weird. Gotta think about that one. Okay, so I was just reading this incorrectly. I was assuming that most of my signal boost was supposed to be here, and I was thinking that this collector was actually coupled to the base through this capacitor, but I was mistaken. It's actually the emitter of this. This is an emitter follower. It's an impedance matching device. Is coupled through the capacitor to this stage here, which is TR402. And the signal coming out of TR402 is huge. So if we go to the base of TR402, we have the tiny little signal that's coming from the emitter of TR401. But if we come to the collector here, then we've got this massive 19K signal, just massive, which is then firing into LC401, which is here, and just kind of hovering around it. I get a little bit of 19K there. So then what we need to do is we need to see if when it comes out of here at D401 and 402, we've got a nice fat signal here. So let's see where D401 and 402 is. That would be these guys down here. These are these 1N34As. And so coming there we've got a big fat signal there and a big fat signal there, and it is appearing like it is doubling, because on the downsides we are getting signal. Let's widen this and see if we can see it a little bit better. Got a little bit of distortion though. Not sure if that's, I don't think that's right. I think it should be cleaner than that, because that's what's going in. Now granted, it is supposed to rectify that somewhat. It's really a doubler circuit. It should be clean. Say we have 38 on one side and we've got 19 on the other. So it is doubling, but there is a bit of loss there. And the distortion kind of bothers me too. Come on, focus. There we go. Alright, so the next culprit here is this amplifier, which is the 2SA678. So we should have, let's see, that's TR403. We should have 14 on the base. Let's first see where it is. Didn't I call it 403 earlier? No, it was 410. Okay, so TR403, which is this weird old Sony device. And on the base, we've got our 38K there. And let's see here. So on the collector, firing into that transformer there, we should have a fairly large signal, if I can get to it. Yeah. Do we have another one that's not doing anything? Alright, let's take some voltage measurements here. So on the base, 14.1, 13.18, that's pretty damn close. And on the emitter we have 7 volts. It's supposed to be 7.5. We have 723, so that looks good. And let's see what we've got on the collector here. We've got nothing in declining on the collector. So yeah, of course that feeds through a 47K to ground, but we should be seeing something here. 2SA678, that's the beast. So let's get a scope on this thing. Yeah, ain't nothing coming out of there. So this very well may be bad too, because the voltages on it check okay. We should see a little bit of voltage here, maybe like 3 volts. I would say about 2 or 3 volts we're supposed to see. Yeah, putting my lead on the collector here, we've got 0. And this should be 47K off ground. We've got a little capacitor we're charging up there, but yeah, it's not shorted. So there's no output from that device. So we need to change that device too. Let's see what a 2SA678 is. Alright, so that looks like a 50 volt, 200 milliampere, 300 milliwatt at about 140 megahertz. So I could probably use, how do they base this thing? Is it just standard Japanese basing? Yeah. So I could use a 2SA1268, 2SA970. I've got both of those. So let's go ahead and swap that out and see if that actually brings it back alive. Given the fact that that's open, that could be why we're getting the distortion on the 38K. Don't know for sure. But let's change it out and let's see what happens. Alright, we're still not quite there yet. But we've got a solid 47K to ground, which is what we should be seeing at that at the collector of that. Still not getting any signal though, which is weird. And see, if we were getting signal here, then that would charge that capacitor there, that what is it, 4.47 at 6.3, which would then turn on that transistor and the lamp. And no lamp, no nothing. Let's see what we look at here on the Scoop. still getting no stereo whatsoever. So let's see, what else? This is intriguing here because we're not seeing any signal here and we're supposed to. Absolutely none. And in theory I should, because with the new device in, the old one had a very low beta, but it wasn't bad. So I've got 7 on the emitter instead of 7.5, and I've got 13.8 on the base, and I've got diddly squat here. Interesting. So I've got that there, 7.5, and then that's part of another switch there, your stereo mono switch. Of course, I don't know if that's working or not working. And I do believe that if I come to this device on the base, let's switch over to the other channel here so we can see it. Oh, I've got a much larger signal now. Interesting. I've got a much larger 38K. I had to reduce the sensitivity. Nothing on the emitter. Got that big thing there. But still no output. I mean, I've got tiny output. I mean, it's really tiny. I didn't have anything before. Tiny, tiny, tiny. So that makes me wonder. I mean, there's 47K to ground there. So there's no dead short. Interesting. Okay, so I think we're getting somewhere finally. I need to look at the bigger picture here. And this is a switch that helps complete the circuit and turn this on. It's not really conducting. We get a tiny little signal here, but it's not really conducting. And this is supposed to have 8 volts on the base, and I've got diddly squat. This is close to ground, which is correct, and this is just 7 volts here floating. And this is supposed to get pulled down to turn this on to cause, this gets pulled down here, which then pulls this down through the collector and turns this on and conducts more. There's 0 volts here. There's supposed to be 8 here. And since this is 22K off ground, there's no capacitor, short, or anything. If I come to R449, which is a 22K resistor, on the high side I've got 11 volts. On the low side I've got nothing. Absolutely nothing. So this is open for sure. So we're going to change the 22K, and then very likely that will turn this on, which will then cause this to conduct more and allow the signal to flow through the final demodulation stage. So that's where we're at with this thing. 22K resistor. Let's see if that does it. Ladies and gentlemen, the verdict is in. The stereo light's on. And now we've got separation, albeit poor. We have it. So there was no voltage getting to the base of this transistor here, which when it's on, its job is to turn this on and cause it to conduct more to pass through the 38 kilohertz signal. So it's now running, and it's running pretty good. We've got separation, albeit somewhat poor. Trying to find a little tool here so we can tweak on this a little bit. And it's a little better. There we go. And let's turn off our sensitivity and see if we can get that notch out. That's as good as it gets. Cool. So we have separation. Pretty awesome. And if I turn the pilot signal way down, way down, and when it starts to come out, blends blends to mono, which is exactly what it's supposed to do. Fantastic. And if I turn the signal down, yeah, it doesn't blend to mono automatically. Just when it loses the pilot. Alright, so cool. We fixed it. We still have a crummy, barely functioning signal meter, which kind of bugs me, but whatever. Let's see, adjusting the threshold on that really doesn't do squat. Yeah, it's got a dead signal meter. Who cares? It's fixed. It's got stereo. The power supply works. The amplifier works. Phono stage works. Everything on it works except that stupid signal meter. And the dial pointer's out, but whatever. But it's fixed. Persistence, troubleshooting, and we're good. So, the next step in this whole mess is going to be cleaning it up, getting the faceplate looking better, and definitely need a dial pointer, because with the tinted glass you're not going to be able to see squat, so we'll change that out. But yeah, it's working. Progress. More stuff to come soon. Thanks for watching.